Namaskar, I am Anand, and all of you are in the live class of Join for Education. In the last class, I have solved up to question number 5 of this exercise. In this class, I shall solve some more or rest question of this exercise. Let's start the solution. So here question number 6. Let's see the question number 6. If the angle between two tangents drawn from a point P to a circle of radius A and the center O. Sorry for interruption. At the recently I have a call. Once again I read the question. If the angle between two tangents drawn from a point P to a circle of radius A and the center O is 60 degree, then OP equal to A root 3. Let's draw the relevant figure to solve this question. Sorry for interruption. A call has come. Once again I read the question. If the angle between two tangents drawn from a point P to a circle of radius A and center O is 60 degree, then OP is A root 3. So this is the relevant figure of the given question. This is a point P. This is the center of the circle. This is the radius of the circle. T is the point of contact. R is also point of contact. PT and PR, two tangents, are drawn from the external point P. Let's see the explanation. From point P, two tangents are drawn given here. OT equal to OR equal to A according to the question. Also line OP bisect RPT. Line OP, this line, bisects the angle RPT. So angle RPT is 60 degree. So the half of 60 degree will be 30 degree. And we know that tangent of a circle is perpendicular on the radius of the circle. So here OT perpendicular on PT. Therefore OTP will be 90 degree. Now we consider in the right angle triangle OTP, then here we see sin 30 degree equal to OT by OP, and we know that the value of sin 30 degree is 1 by 2. The value of OT is A according to the question by OP. Now by cross multiplication we get this step. So here OP equal to 2A. Hope that there is no problem to understand up to this step. So here OP equal to 2A, but in this question said us OP equal to A root 3. So this is a false statement. Hope that there is no problem to understand the explanation of the question number 6. So let's see the question number 7. This is the question number 7. The tangent to the circle of an isosceles triangle ABC at A in which AB equal to AC is parallel to BC. Hope that there is no problem to understand the question. Let's see the explanation of this question. So, see the explanation of the question number 7. This is the explanation of the question number 7, and this statement is true. Let's see the explanation. This is the relevant figure of the given question. Let EAF, EA, and this is the F, tangent to the circle of the triangle ABC. So this is the circle of the triangle ABC. In this question, said us to prove EAF parallel to BC. We have angle EAB, this angle, equal to angle ACB. Angle between tangent and chord is equal to the angle made by the chord in the alternate segment. Hope that there is no problem to understand this statement. Here AB equal to AC given, so this angle we equal to this angle, and AB and AC are equal. Therefore, this angle will be equal to this angle. So when two angles of a triangle are equal, then the opposite side will be equal. So the opposite side of this angle is AB, and the opposite side of this angle is AC. So here AB equal to AC. So this is a true statement. Hope that there is no problem to understand the explanation of question number 7. Let's see the next question, or question number 8. Now I am going to read the question number 8. This is the question number 8. If a number of circles touch a given line segment PQ at a point A, then their centers lie on the perpendicular bisector of PQ. Hope that there is no problem to understand this question. Let's see the explanation of this question. This is the explanation of the question number 8. This is a false statement. Explanation is in this way. Given that PQ is any line segment S1, S2, S3, S4, circle touch the line segment PQ at any point A, let the center of the circle S1, S2, S3, S4 be C1, C2, C3, C4 respectively. Let's see the relevant figure of this question. S1, S2, S3, S4 are the circle, and C1, C2, C3, C4 are the center of the circle. So center of the circle lie on the perpendicular bisector of PQ. This is the PQ, and A is the perpendicular bisector or bisector of PQ, or A is the midpoint of PQ, and A is a common point of the tangent PQ, and radius of the circle S1, S2, S3 and S4. So we know that radius of a circle is perpendicular on the tangent of the circle. So see here, joining each center of the circle to point A on the line segment PQ by line segment C1A, C2A, C3A, C4A and so on. We know that if we draw a line from the center of a circle to its tangent line, then the line is always perpendicular to the tangent line, but it does not bisect the line segment. So this is a false statement. Hope that there is no problem to understand the explanation of the question number 8. Let's see the next question of this exercise, which is question number 9. Let's see the question number 9. If a number of circles passes through the end points of P and Q of a line segment PQ, then their centers lie on the perpendicular bisector of PQ. Let's see the question number 8 and 9. There is little bit difference. Then their centers lie on the perpendicular bisector of PQ, and here said their centers lie on the perpendicular bisector of PQ. Let's see the explanation of question number 9. So this is the question number 9, and this is the relevant figure of the question number 9, and this is a true statement. Let's see the explanation. We draw two circles with the center C1 and C2 passing through the end points P and Q of a line segment. So PQ is the line segment of the circle whose center is C1 and the circle whose center is C2. We know that the perpendicular bisector of a chord of a circle always passes through the center of the circle. Of that, there is no problem to understand this statement. So, perpendicular bisector PQ passes through C1 and C2. Similarly, all circles passes through the end points of line segment PQ will have their centers on the perpendicular bisector of PQ. Hope that there is no problem to understand the explanation of this question, and this is a true statement. Let's see the last question of this exercise, which is question number 10. Let's see. AB is a diameter of a circle and AC is its chord such that angle BAC equal to 30 degree if the tangent at C intersects AB extended at D, then BC equal to BD. So this is a true statement. Let's see the explanation of the question number 10. This is the explanation of the question number 10. This is the relevant figure of the question number 10. Join B and C order here ask us BC equal to BD. So this is the BC and this is the BD and this is the BC. We join here BC and OC. BC and OC. OC is the radius of the circle. OA is also the radius of the circle. So radius of the same circle is the same. Therefore, this is the 30 degree. Therefore, this one will be the 30 degree. Hope that there is no problem to understand this step. And we know that angle between tangent and chord is equal to angle made by the chord in the alternate segment. OC is perpendicular on CD. This is the OC and this is the CD. CD is the tangent and OC is the radius of the circle, and we know that tangent is perpendicular on the radius of the circle. So here will be OA equal to OC. Already I have told OA equal to OC. Therefore, angle OAC equal to angle OCA equal to 30 degree. Already I have cleared. So angle ACD equal to angle ACO plus OCD. Angle ACD, it means that this angle equal to this angle plus this angle plus this angle. So ACO plus OCD, ACO plus OCD. So this is the 90 degree and this is the 30 degree. Therefore, this one will be 90 degree plus 30 degree equal to 180 degree. Of that, there is no problem to understand up to this step. In triangle ACD, let's see here, angle DAC plus angle ACD plus angle CDA. We know that sum of three angles of a triangle is 180 degree. Angle DAC is 30 degree. Angle ACD is 120 degree. Therefore, angle CDA, the addition of these two move in the right hand side, then this one will be the minus. So 180 degree minus 120 degree plus 30 degree equal to 150 degree. 180 degree minus 150 degree equal to 30 degree. Therefore, angle CDA equal to angle BCD. Angle CDA, it means that this angle equal to angle BCD, it means that this angle. In the triangle CDB, this angle and these angles are equal. So this is an isosceles triangle. So the opposite side of this angle is BD and the opposite side of this angle is BC. Both BC and BD will be equal. So there is no problem to understand the explanation of this one. And here written BC equal to BD. So this is a true statement. So half that there is no problem to understand the explanation of the question number 6, question number 7, question number 8 and question number 9 and at last question number 10 of this exercise. Let's solve some more questions of exercise 9.3. Let's see the question. Let's start the solution of questions of exercise 9.3. 9.3 has also 10 questions. Out of the two concentric circles, radius of the outer circle is 5 centimeter and the chord AC of length 8 centimeter is a tangent to the inner circle. Find the radius of the inner circle. Of that there is no problem to understand this question. Let's see the solution of this question. So this is the relevant figure of this question. Here O is the center of the both circle and C1 and C2 are the two concentric circle and AC is the chord on the circle of the center C2 and AC is the tangent of the circle whose center is C1. Of that, there is no problem to understand this figure. We join here O to D, and also OD perpendicular on AC, because we know that tangent of a circle is perpendicular on the radius of the circle. Here, let's see, AD equal to DC equal to 4 centimeter, AD equal to DC equal to 4 centimeter. So total length is the 8 centimeter and D bisect AC. So half of AC equal to 4 centimeter, and half that there is no problem to understand up to this step. In right angled triangle AOD, OA is the hypotenuse, and OD and AD either perpendicular or base respectively. So we consider in this triangle, so OA square equal to AD square plus OD square. We applied here Pythagoras theorem or Pythagorean triplet. Of that there is no problem to understand at this step. Now putting the value of AD and OA, the value of OA and value of AD is given. When we move AD square in the left hand side, then in the right hand side we have OD square. After the proper arrangement, I am going to write here OD square equal to 5 square minus 4 square, and s square of 5 is 25 and s square of 4 is 16. So 25 minus 16 equal to 9, and the square root of 9 is 3. So so OD is 3 and radius of the inner circle is 3. Of that there is no problem to understand the solution of this question. Let's see one more question of this exercise. So this is the next question or second question of this exercise. Two tangents PQ and PR are drawn from an external point to a circle with center O. Prove that OQRP is a cyclic quadrilateral. If we have proper idea about the cyclic quadrilateral, then we have no problem to understand this question. Let's see the solution of this question. This is the first question of the exercise, or sorry, second question of the exercise 9.3. So this is the relevant figure. This is the external point. R and Q are 2 points on the circumference of the circle, and tangents are drawn from point P to R, which is a point on the circumference of the circle, point P to Q, which is a point on the circumference of the circle. So ORP equal to 90 degree and OQP equal to 90 degree, and half that there is no problem to understand at this step. We know that tangent of a circle is perpendicular on the radius of the circle. So radius is perpendicular on the tangent. So OQ is perpendicular on PQ, and OQP, this is the 90 degree. Sum of all interior angles are 360 degree. This one plus this one plus this one plus this one equal to 180 degree, and this is the 90 degree and this is the 90 degree. So this is the 180 degree. So this one plus this one will be 180 degree. We know that sum of all four angles of a quadrilateral is 360 degree, and sum of these two angles is the 180 degree. Therefore the sum of this angle and this angle will be 180 degree. So angle Q plus angle P equal to 180 degree. So PRQ is a cyclic quadrilateral. Hope that there is no problem to understand the solution of this question. In the next class, I shall solve some more questions of this exercise. Till then, thanks to all of you. Thank you very much to stay with me in the live class of Join for Education. तो ज्वाइन फॉर एजुकेशन के आप लाइव क्लास में थे, उसके लिए बहुत बहुत धन्यवाद। आप लोगों से आज मैं कुछ भी नहीं पूछा, आपका वीडियो भी मैं आज ब्रॉडकास्ट नहीं किया, केवल मैं अपना ही वीडियो ब्रॉडकास्ट किया। नेक्स्ट क्लास will be depend upon or according to your requirement in mathematics, science and other subjects. Once again, I thanks to all of you. Thank you very much.